Good morning, good afternoon, and good evening, depending on where you are. Thank you very much for joining to our first OpenEBS Hangout. So a couple of ground rules. I request the audience to keep themselves mute and post the questions on the chat window. We'll try to answer either in the middle or towards the end of this Hangout. Myself, I'm Uma Okara, CEO and co-founder of CloudByte, core team member of OpenEBS. Today in our first Hangout, we're going to talk an overview of OpenEBS, and also we talk about what has been released in 0.2 and then what's cooking up in 0.3 release. And we have a cool demo for Kubernetes 1.6 sandbox setup. We simplified to set up the installation of Kubernetes to do it in one go. And then we also have a demo for setting up OpenEBS for on-prem data center use case. And then we'll probably go through some discussion about community building, as well as any questions that we'll have on OpenEBS. So with that, instead of waiting for it, we want to really kickstart the demonstration of Kubernetes 1. What we did is we simplified most of the complex steps into a simple vagrant file. This installation could take probably anywhere from 30 minutes to 1 hour. Yes, within 1 hour you can bring up Kubernetes. Why don't I start this, and then while the installation of Kubernetes is going on, we'll talk about overview of OpenEBS and a few other things. Let me show you how to kickstart this OpenEBS stuff. We have the installation.
Thank you for thinking about me.
We see some audio from the folks there. Request them to keep them in mute. Just go back. We could install Kubernetes with a simple vagrant up command, which I did, and it's going on. Let me just talk about what is OpenEBS. OpenEBS is containerized storage for containers. If you see, the application pods have been running on top of Docker. And if they are stateful applications and they need storage, the regular way to connect them to storage is using some kind of plugins. With OpenEBS, we're going to move away from that. And we are actually going to move the storage volumes to the application pod itself. So we containerize the storage volume, and so that they can be part of application pod. And once you keep the storage volumes as part of the application pod, the management of storage volumes become pretty automated. The application management takes care of the managing of the storage volumes as well. So this is how we really solve the persistent storage issue for containers. That's one main difference with OpenEBS. And because we containerized, we also solve the typical problem of storage upgrades in production environments. With storage volume containerization, storage becomes a microservice, and then you can upgrade the storage at a volume level. This is the main difference between the legacy storage or any other open source storage and OpenEBS containerized storage. So that's a quick overview of what is OpenEBS. And let me talk about our vision. OpenEBS vision is to secure and serve the data for dynamic container-based environments, making it easy and safe to run the persistent workloads, very, very similar to the stateless workloads. We all know the stateless workloads on container environments are a reality today. Let me dig a little bit deeper into this. With Kubernetes, you can take ML file and express the intent of the configuration of the stateless workload, and it all gets done. It's simple and easy. What about the stateful workload, right? So stateful workload is going to require a persistent storage, and the persistent storage coming from various tiers is really hardwired through a plugin into the containers. So it's not easy. It's possible to run stateful workloads today, but it's going to require a careful configuration and handholding of Kubernetes orchestration to get the stateful application going, because things are so tightly coupled. The storage volumes are so tightly coupled to the application parts. And this is exactly our vision to change them into make it as easy as the stateless workflow. So with OpenEBS, you're going to change the workflow of stateful workloads so easy that you go and put your intent into the YAML file, and we're going to take those policies, that intent, convert that into policies, run through our API engine, and volumes are going to be provisioned depending on what's the right place to provision, and then they get containerized, and then they get moved to the application pods. So with OpenEBS, you're really going to use the same workflow that you've been used to use with stateless workloads, and it becomes so simple all of a sudden. The problem of storage, persistent storage management will go away. And that's really what we want to solve with OpenEBS. And we started with that vision. We're already having a usable release, and there's a lot of work to be done. We'll get there, but the first pieces of this initiative has already been done and is available. All we are saying is, with OpenEBS, the DevOps operations will become so easy that the DevOps operators and users will feel that, hey, storage operations are really easy and they're off my back. And now with OpenEBS, I should be able to go get my storage rolling into production quickly and easily without any hassles. So that's what we really want to get to. So we have our first steps already done, and how we built it is really the storage containerization part is built using Docker, and the orchestration, it's a no-brainer. Kubernetes is the right orchestration platform, the most popular one, and the right one too. And we are using for the basic provisioning of storage and monitoring of the storage with OpenEBS. And storage also will have deep operating procedures with respect to data protection and smart capacity management, et cetera, et cetera. So what we have done is we introduced an extending piece of orchestration to Kubernetes called Maya. So Maya will be doing the backend storage operations in addition to the basic provisioning. Those will be something similar to predictive analytics, making sure that the right volume is running on the right tier or the right node, et cetera, et cetera. And Maya also exposes AWS EBS like APIs, so that the on-prem cloud or hybrid cloud integration becomes easy. I can move the workloads from one cloud to another cloud pretty seamlessly. And for the core storage features, we took some parts from Longhorn, Rancher Longhorn. You may have heard about it already. For the basic block storage functionality, We've used Longhorn, but we are building a lot of enterprise-grade storage functionality into that. Those will include the high availability, which is enterprise-grade, smart and intelligent QoS, and we are really making the distributed scale-out component part of this core OpenEBS. Also, we are going to introduce smart tiering for higher performance. This is where the latest and latest of the hardware from memory perspective is going to be utilized very well. Either it is NVMe flash or technology, we're going to use all those technologies and do the tiering in such a way that you will get the best performance as much as possible from the underlying hardware. So all those will be part of OpenEBS. So let me also talk. Let me introduce our chairman, Evan Powell. He'll be talking a little bit about the team who's behind this OpenEBS project. Evan, want to?
Yes. First off, thank you for everyone joining. And let me tell you a little bit about why I joined. Why I joined OpenEBS in the first place. Hopefully you can hear me all right.
Yes.
Yeah, good. What I saw was a lot of storage expertise, building a system where handing it in the storage world for years. I know firsthand there's no substitute for experience building and running these kinds of systems. But then in addition to that, I saw the opportunity to DevOps like use cases. Really today, getting to know doing it and the real team actually doing it. And so, of course, founder, Jen is running engineering. Really deep team at OpenEBS. That's why it's so quickly. That's just thank everyone for joining. Really excited about this team that we have, and Uma, maybe I'll hand it back over to you and go from there.
Yeah, thanks, Evan. So with that introduction, I really want to talk about what we did earlier in our past few years. This team has built a production-grade enterprise Elastic Store, which is a unified with most of the latest functionality that you would see with other enterprise products, including quality of service and enterprise HA, multipath to various underlying storage, disk management layers, etc., etc. So what is interesting about Elastic Store is we really built the storage containerization into this product 3 years ago, and we've been running in production in various places. It's just not open source. So with OpenEBS, we're taking all that experience and putting that experience into working with OpenEBS. So we're pretty excited about it. And this team, I'm proud to say that the team has deep storage experience with Evan coming in from Stackstorm. He carries a lot of DevOps experience, and the team has done hundreds of non-disruptive upgrades of storage and production, which everybody will agree with me is no easy task, and that carries a lot of real-time experience. And all that we are hoping to put into OpenEBS making. Either it's the way we implement our machine learning modules or predictive analytics, etc., etc. All of this learning is going to come back into helping us build a better product of OpenEBS. So that's our vision, how we built it, why we are building, and who's building it, etc. And before we go and talk, take a look at this demo, let me show how a typical OpenEBS is deployed, right? We try to make it as simple as possible. Step one would be you take an existing Kubernetes minion environment, and then you want to put OpenEBS on top of it. And we simplified it using a Maya operator. So OpenEBS operator, you just download and then run it. That will go and install the required components automatically onto the minions. And it's a simple matter of the configuring application pod YAML. You just go and specify your storage volume information into the application pod, and your application volumes, the storage volumes get automatically provisioned, and they can be connected to the application. So as you can see, the entire workflow of bringing in OpenEBS into Kubernetes minions is done using a simple Maya operator. And once you install it, it's a matter of we are all used to managing the application YAMLs, and managing storage for those applications will be just an extension of adding the configuration of storage file. So that's the extend to the storage as well. With that introduction, let's go back and look at how our the demo of installing Kubernetes with Vagrant is coming up. And also, I will request Kiran to later talk about the project updates and carry forward the demo. Kiran, it's yours.
Hello everyone, good morning. So one of the things that would make this Hangout very interesting is if you post your questions on the Hangout, we'll probably try to answer as many as possible today, right? So when we started off with this presentation, we went into a different window to issue a command. We'll first check the status of that command, and then I'll proceed with the presentation. All right, it's like this actually finished. Let me show you what we really did here. So we created a new sandbox folder for Kubernetes, and then we went into that folder, got the Vagrant file. I'll talk about this particular Vagrant file in a bit, and then we just issued the Vagrant status in the Vagrant command. Now let's look at the Vagrant status, and we were able to bring up a Kubernetes cluster with one master and one minion node. Right? I'll just get back to this demo in a bit. So let's quickly look through the slides. All right. So just carrying on with what Uma said, one of the things that, with that overview, what we really want to convey is OpenEBS is containerized storage for containers. Then just like how Flannel and Calico kind of certain piece of Kubernetes, OpenEBS owns the storage part of it. OpenEBS currently is the only completely open source solution built for storage for containers. Some users might say that I run OpenEBS just like the way I run Kubernetes or EBS, right? And the real one is the OpenEBS is, the vision of the OpenEBS is to take away the storage operations from, the burden of storage operations from the developers and the operators. All right. So why did we really start with this sandbox? Just wanted to share the learnings that we have had in the last couple of months trying to get Kubernetes to working. So if you look at the typical developer or operations team's workflow, his Percona service or let's say Bitbucket, he wants to launch it on Kubernetes, right? The first stages are really the exploration or experimentation phase. What you really need is you check out the source code of whatever you want to run in Kubernetes, or they create the YAML files out of it and then try to run it in Kubernetes cluster, right? So this can be an iterative process where you're trying to repeat your YAML configurations, etc., right? And this is all before you actually commit back into the GitHub, which will then go into our regular CI and deploy, right? So there is a phase before we actually commit into the GitHub. We want to validate whatever we have done is right. So that's where we typically run it in the sandbox. Okay. This is similar to like any other, let's say I'm writing a web application, I have a Tomcat, or if it's in Java, I have a Tomcat server running. I run my application in my local Tomcat before I actually deliver it to the outside world, right? So with Kubernetes, I want a sandbox environment where I want to verify whether the YAML files that I have written really work, right? So typically, I would need a multi-node K8s cluster, especially if I want to test for high availability, scalability, performance, that kind of aspects. And then I would want to be able to configure the type of pod networking scheme that I want to use, or the type of storage scheme that I want to use, right? And depending on what I choose, there could be like different configuration steps involved in that. And the thing about sandboxed environments is I should be able to recreate them at my will. Either I'm connected to the network or not, whether it really depends on, my network connectivity to it locally or in the cloud. Most of the times with these initial stage of the project is to kind of get it working in my local setup, then share it with a wider audience, a team, or like an upper management to kind of take it forward and see whether this solution is really viable or not. So in all these cases, we need a sandbox environment for Kubernetes, right? Now let's look at what are the ways that are available to set up Kubernetes. So if I go to the Kubernetes documentation, there are, probably like, 50 plus options that are available there, which is kind of a cool thing that there's so much. Most of those options are actually provided by the community. So it's a very popular orchestration engine for containers, right? But if you look closer at them, you can kind of see that they are on this spectrum where most of them are concentrated towards the cloud. So obviously, like most of these big companies want to provide container service in their cloud, either in the form of hosted solution or some customized solution. Then you have a bunch of things like, OpenShift that's helping you to build on-premise Kubernetes clouds, and also like, the projects like Conjure and Cargo, etc., right? There's a lot of focus from the virtualization world also to kind of bring Kubernetes into their data center. Right. But if before you get into production with this on-premise or cloud setups, you still want to have a setup that's for your experimental stage, right? So that's where you basically are limited to very few options. One is like Minikube and Minishift, which really fall into the category of beginners, which kind of set up everything on a single node. But if you want to, so you have learned what's Kubernetes, and now you want to take it a step forward, build like really interconnected application, then you are left with tools like KubeADM or Juju that lets you write some scripts around KubeADM and Juju to kind of bring up a multi-node cluster for you, right? So I haven't explored Juju much, but the learnings from really using KubeADM for setting up a Kubernetes cluster At the onset, if I just look at the documentation, it's pretty straightforward. It's just a 3-step process. It says, you can initialize a Kubernetes master using kubeadm init, and then you configure the pod networking. It gives you different choices for doing that. And then it says, you just note down the token and you can kind of add nodes to that, right? All this is pretty simple, but when you really get to start using kubeadm, you'll notice that my development process itself is very iterative. So once I have this set up, I may have to recreate it like in a day or two, or like, in a week's time. And every time I run these commands, it ends up getting the latest repositories, latest packages from the repositories, which may really not be compatible. For example, like kubeadm latest repository may not be compatible with the Kubernetes kubelet or the API server package that's downloaded, right? We have recently had these issues with 1.6 release of Kubernetes, and then we also hit the similar issue with 1.6.1 as well, right? In addition to this, this downloading the base package like kubeadm from repository and depending on the network to download all the other images to be launched, it creates a lot of network dependency. And it doesn't really help my case if I want to demonstrate a HA in a environment where I may not have network connectivity. Let's say like I've gone to a meetup, or like I'm presenting it in a conference room that doesn't have a proper network, right? In addition to this, when we are using the networking schemes, some networking schemes ask us to specify certain parameters, which are not very straightforward. Like, for example, after configuring the we need to kind of change some permissions to user mode so that the networking works, etc. Right? And the compatibility kind of continues. I have a slide that kind of shows what are the other challenges that we recently saw. Kubernetes, for example, is like a very vibrant community, and there are like a lot of people collaborating, and very neatly governed project, I would say, where features get introduced in the alpha stage, and then they go to beta, and then the version gets released, and then you can kind of introduce again, like version 2, alpha, beta, v2. But let's say if my project depends on a feature that's in the alpha stage, there's really no guarantee that the API will remain the same in a week or like 2 weeks when this active community kind of fixes it and then releases like maybe a better solution or like a more secure solution, like the way it did with the API server. Right now, 8080 is completely gone, and you can only by default run with 6443. So if I had some wrapper scripts around kubeadm that depended on certain port to be available, they all fail, right? Similarly, the way the storage is attached to the kubelets, the default functionality has changed in 1.6, right? It kind of breaks most of my flex volume plugins that that we're working in 1.5.5. Right? Similar to Kubernetes, kubeadm also has a lot of alpha, beta features kind of a thing, and then they keep changing the options to use for certain parameters, right? So we had this situation where we had to present, or like, we wanted to make the release of 0.2 with everything was working fine, and then 1.6 releases and it stops working, right? That's when we kind of felt the need for creating an reproducible sandbox Kubernetes environment, which can work every time you run it, right? So what we came up with is basically creating an Ubuntu-based VirtualBox image and Vagrant box with all the dependent packages already downloaded and inserted, and also packaged with the configuration scripts for that particular version, right? So I just had to have this one Vagrant file that will get the Vagrant box and set up the cluster the way I need it. By the way, this OpenEBS is completely open source project. The boxes are available on the Atlas website for everyone to use. And even the code that actually generates the 0.2 with everything was. All right. kind of shows the nodes that are created. And this is a 1.6 Vagrant box, and currently the supported version is 1.6.3. Then pods. All right. Set has all the required services running. So before I came up to this one, I kind of showed that along with the Kubernetes, configuring it with the View network, it also installs a OpenEBS Flex Volume driver. This driver is configured to right now work with OpenEBS 0.2 release. OpenEBS 0.2 release is a dedicated setup. So this Vagrant file allows you to bring up the OpenEBS Maya host also, right? But in case if you are someone who just wants to bring up Kubernetes cluster, that also can be done. The Vagrant file itself is programmable. The instructions for doing that are on the GitHub. Right. So now let me just quickly get the IP address of the Maya master. So Vagrant SSH. .5 is the API server address. So these Vagrant boxes also ship with a bunch of sample pod specification files. For today, I'm going to run the Percona service. This is a simple single node Percona instance. All I need to show here is it uses the VSM Wall 1, and the VSM Wall 1 is configured to be provisioned via the Flex Volume on OpenEBS. And I need to specify the IP address of the OpenEBS server, which we found to be 5 on this setup. Okay. That's it. So it will go ahead and provision the storage on the OpenEBS and then launch the Percona. So what it really does in the backend is when we launch that particular pod, Kubernetes API scheduler, API server and the schedulers will choose the minion node on which to run. In our case, we just have one node for now. And that we have configured that stateful app pod YAML to talk to the Maya master. So it will issue a request to the Maya master to provision the storage. That goes and configures the storage containers on the storage host, which again are nothing but Docker hosts, and these are like storage delivered via the containers. Once the storage is available, it's going to on to the minion host using iSCSI, and then it's going to provide that as a volume mount to the Percona container in this case. Okay. So still in the process of creating it. Meanwhile, we'll check if it has created the volume on OpenEBS. So similar to kubectl, for storage related operations, we can actually use a CTL, which we call as Maya. PSM list is going to tell, okay, it's actually already provisioned. I can get a few more statistics on this one by running this command. So this just tells me that the iSCSI service is available on the 131 IP address. It's a volume that's specified to be created with 5 GB space, and the storage is back to a couple of replicas, 143 and 142. And I can see that the storage is getting updated, which means the container would have started and the database must be getting initialized. So let me go back and check that. Come out of this VM. Yes. Yeah. So it's basically as simple as that. To use the OpenEBS storage, we don't really have to go and provision any volumes on the storage itself. We can control the behavior via the YAML file of the application itself, right? Okay. I'll probably quickly go through the project updates. These are anyway already available on the website. As Uma mentioned, we released the 0.2 in April, and that version can be used to already try out some of your applications. One of the cool things with this release was we had a lot of good discussions with the users of OpenEBS, and they kind of gave us some feedback in terms of what they want to really see in the next release. So some of the things that people wanted was, we want to really have hyper-converged storage. We don't want to have it as an external thing. So currently on 0.3, this is what we are working on as a top priority. In addition to that, once it's hyper-converged, if there are extra disks on that minion nodes, that can be also used for storing the persistent data. That's basically via our storage manager. That's also being done. In addition to that, we also implemented the Ansible CI framework, and some work is going on in terms of how to run OpenStack Cola on OpenEBS, and how do we kind of launch data science notebooks on Kubernetes and OpenEBS, right? Couple of other community updates. We are going to be hosting a Golang meetup in Bangalore next month. It's co-hosted with Red Hat guys. And Evan and Huma have been busy trying to spread the message of containerized storage and how it can help the DevOps workflows, etc. Evan just finished a talk yesterday at the storage conference. And by the way, we are hiring as well. All right. So one of the feedback or the use cases that people saw was, how to build an on-premise EBS solution using OpenEBS. It's kind of a great way to deploy OpenEBS. In line with trying to keep everything simple, we have kind of automated the steps with Ansible to install it in your premises. So a typical setup could look like this. Let's say you have virtualization hosts or container hosts, or let's say some bare metal servers that need storage. If they want to consume storage like the way they consume storage in the Amazon EBS, all we need to do is install the OpenEBS Maya master like the way we showed, and then configure it with a bunch of storage hosts. The API for configuring the storage is something similar to EBS. And we also support scale out. So in case the storage runs out, you can horizontally scale up the storage. right? The next 5 to 10 minutes, we'll just walk through the Ansible code that we have written. I'll not spend too much on the slide here, and we'll get into the demo. So basically, we have automated the process of generating the inventory. You're already familiar with Ansible, so it needs an inventory file and a set of roles defined for each machine, and a playbook that is going to kind of configure the role for a machine, right? So one of the inputs is machine.in file for us, where we define which machine has to act as a storage master or the storage node. Let me just show that. Okay. In this case, we want to bring up 2 storage hosts and 1 master, and this is really the role that we want to define for it. And this one sets up the passwordless SSH to the nodes and all. In the interest of the time, we already have one setup. We can probably show. We'll show the command to kind of set it up. Okay. Using that input file, it created 2 groups of servers, one for Maya master and one for Maya host, and specifying what needs to be installed in each of them. Right now, we will go into the setup file. Okay, just tells you that on the Maya master, you need to install all the dependencies related to the role master and for the role host. Right? Probably walk through what each of those mean if there is time. So let's actually try. Okay. So on this machine, while this is going on, we already have this setup on a ESX VM, right? And it has 2 nodes that are configured. There are no volumes that are running on this one. Right. Now we'll launch an container that will provision the storage on this particular setup. Right. It's just creating a Docker container that will run an iometer test. Okay, so said the playbooks are also available on the OpenEBS repository under the E2E Ansible. And the roles that I mentioned about are in this directory here with the tasks defined for each of those roles. Right. So what we really wanted to do with this was to build an end-to-end testing framework, but it kind of helped us to also use this as a provisioning or a deployment tool. So what we just saw was how it can automatically generate the inventory files. It also has the feature of resyncing with the new host that you add to the machines.in file and updating the host file. So we already had an OpenEBS storage setup on the ESX VMs, but you can pretty much do it on any other nodes also. If you observed, if they were VirtualBox VMs, then if there are any dependencies with respect to like what kind of network you want to use, all those are also configurable via the Ansible config file. And then there is a global variable file that we also use for that. And right now we are trying to provision the storage for running an IO meter test. Right. Okay. There was a volume that was automatically mounted. So let's actually go and look at this command again. So we have volume, that was a name that we chose here. And then stats. Watch. As the IOs are getting pumped, the indexes of the particular volume in each of the replicas are synced and are getting updated, right? And the test IO meter is such that, you know, until you kind of interrupt or like close the test, this is going to be running. Okay, that's pretty much what I had in terms of showing the demo. I'll hand it back to Uma. Thank you, everyone.
That was very nice. You were able to show the demo of Kubernetes installation through Vagrant file, as well as how to deploy EBS-like platform on-premise. So those are the topics that we really wanted to cover, and we're hoping to have some questions. We received some online, offline questions through email. So one of the questions is, you know, what's coming next in terms of community building. So basically, you know, we are continuing to have this online hangout on a monthly basis. Probably the next hangout is planned in a 1 month time from now, and we will have some cool topics around data science, how to use data science applications with OpenEBS as an underlying storage, some innovations around that, probably Apache Spark and OpenEBS together, how can they work together, etc. We'll talk about it. So again, thank you very much for joining us on our first Hangout. That's all we have for now. I'll probably wait for a couple of more minutes to see any questions that come on the Hangout.
Hey, Uma, it's Evan here. Can you hear me?
Sure.
Yeah, just
yes.
Quick comment. You know, the part of the interesting thing about these demos is we're demonstrating in real detail how it ties together, and so we get into the real details, of course. And yet, what we're actually demoing is that when it's up and running, tied into your Kubernetes, absorbing intent, therefore, from your developers, you actually should have to do a lot less storage admin than you've ever really needed to do before. So it's an interesting demo in that regard, right? We want to be transparent and show you all of the underlying pieces that go into actually running this. We want to show you it running, but one takeaway should be a lot less pain in management overhead, at least when it's well tied in, than, let's say, other you know, plugin based integrations into your containerized environment. So it's an interesting challenge with a demo. Show the details, and part of the details we're showing is how you're not going to have to sweat the details quite as much when this is up and running.
That's right. That's right. So we didn't do any volume provisioning. You go to your node, bring everything is done very, very seamlessly. So yeah, you're right. We did a lot of storage configuration without actually doing it. right? So it's all automated, and that's part of what we are trying to do to storage operations very simple. Yeah, you're right, Evan.
Yeah.
That's the key takeaway. And also, we are going to record. We recorded this the demo on the Hangout. We'll be posting it in the next couple of days' time on our website, and probably tweeting it out. And run through the demo once again. And we're always there on our Slack channel to help any queries that you may have. All right. Anything else you want to say, Evan?
No, that's it. Those.
Again, for joining us and making this a successful event, we'll be posting this video, and keep an eye on us on Slack channel. Thank you. Bye-bye. Have a good day.
Bye-bye.